Hi there, we'll talk about the universal law of gravitation today. So if there are any two objects on say the earth which are having, so say this is our object A, this is our object B, with M1 being the mass of object 1 and M2 or object A and M2 being the mass of object B. And let's say these two objects are kept at a distance of D, then this universal law of gravitation was discovered by the great Sir Isaac Newton. What point Newton makes is that the gravitational force is directly proportional to the two masses which are having the gravitational force of attraction between them, or rather the product of the two masses in which there is a force of attraction. So F is directly proportional to the product of the two masses, which is M1 and M2. Also, the force is, let's call this as statement 1. The force is also, secondly, as per Newton, the force is inversely proportional to the square of the distance between two objects. So, two aspects about the Newton's universal law of gravitation. The two objects which are at a distance d, these could be any two objects on the earth, object A and object B, where M1 is the mass of object A, M2 is the mass of object B. So force is directly, as per the Newton's law of gravitation, force is directly proportional to the product of two masses, M1 and M2. Also force is inversely proportional to the square of the distance between the two objects. So if I say combining 1 and 2, if I combine statements 1 and 2, I get F is directly proportional to M1 M2 upon D square. F, or the force, is directly proportional to M1 M2 upon D square. When we remove the proportionality sign, there is always, so suppose there is any random x proportional to y. When you remove the proportionality sign, typically in the RHS there is always some constant. This constant can take different forms in different cases. Here, after removing the proportionality sign, our constant is going to be capital G. This capital G is an important constant. It is termed as the universal gravitational constant, 6.673 into 10 raised to minus 11 Newton meter square per kg square. Capital G is the universal gravitational constant, which is 6.673 into 10 raised to minus 11 Newton meter square per kg square. Once again, summarizing this law, there is some kind of attraction between every object on the earth or in the universe with every other object. So if you're talking about the earth, it could be the earth itself and another human or any two objects on the earth. Let's say those two objects have masses M1 and M2. We have object A which has a mass M1, we have object B which has a mass M2. As per the Newton's universal law of gravitation, force is directly proportional to the product of the two masses which are supposed to be having a force of attraction between them. Force is inversely proportional to the square of the distance between the two objects with masses M1 and M2. So F proportional to M1 M2, we call that as statement 1. F proportional to 1 upon D square, we call that as statement 2. When we combine statements 1 and 2, we get F proportional to M1 M2 upon D square. When we remove the proportionality sign, F is equal to capital G, m1, m2 upon d square. Our constant is capital G. Capital G is a fixed value of 6.673 into 10 raised to minus 11 Newton meter square per kg square. As you all know, in this final expression of the Newton's law of gravitation, mathematical interpretation of the Newton's law of gravitation, F is the force or the gravitational force of attraction. G is the universal gravitational constant, which is a fixed value of 6.673 into 10 raised to minus 11 Newton meter square per kg square. M1 is the mass of the first object. M2 is the mass of the second object. Small d is the distance between the two objects. So this is as far as the universal law of gravitation is concerned. Thank you guys.